Good morning from Copenhagen to all our participants joining us from Zambia, from Mauritius and beyond. Welcome to the final day of our virtual training on building energy efficiency. It's a pleasure to have you with us once again. We hope you found the past sessions as insightful and engaging as we have. This training is part of the broader Global Platform for Urban Climate Neutrality initiative. It is a central hub designed to support cities in emerging economies with access to knowledge, technical solutions, capacity building, and implementation support. All of this is aimed at accelerating progress in energy efficiency and long-term carbon neutrality for cities. The GPUC project is made possible through the support of DANIDA under Denmark's Ministry of Foreign Affairs and DINA, the German Energy Agency, with UNEP CCC serving as the implementation partner. Over the past 2 days, we've covered a lot of ground on the critical role of energy efficiency and how it plays in the building sector. On day 1, we looked at why energy efficiency matters, especially when it comes to reaching our climate goals. We heard from government representatives from Mauritius and Zambia who shared in-depth perspective on the unique challenges their countries are facing and the ambitious targets that they've set and what support is still needed to get there. We also touched upon a variety of strategies, both active and passive measures, and got an introduction of the EDGE tool, which is helping unlock green finance for buildings across Africa and beyond. IFC's implementation projects gave us some real-world context to the tool, and the panel discussion highlighted the challenges surrounding the financial gaps and limited awareness, which were echoed by both Zambia and Mauritius. Then yesterday, we focused on policy and regulatory frameworks, what they look like, how they're applied, and how they can work in different contexts. We explored tools like regulation, incentives, and information instruments, and learned from the experiences of Zambia, Mauritius, and Ghana. We talked about how nature-based solutions and energy efficiency can go hand in hand to deliver sustainable, long-term outcomes and the opportunities for multi-stakeholder collaboration in the building sector. The conversations have been rich, the questions insightful, and your engagement truly inspiring. Today, we are again joined by an outstanding panel of experts who will be guiding us through the sessions. We have Zhuolun Chen from UNEP CCC, who is a senior advisor in energy efficiency and green finance with over 25 years of experience in international project implementation. He is a chartered mechanical engineer on HVAC systems in China since 2011, a lead AP, and a chartered financial analyst. His work focuses on implementing energy-efficient buildings and communities through integrated building performance simulations with climate-adaptive design solutions and green financial mechanisms. We also have Lenore Cairncross from IFC, who is leading the EDGE Green Building Transformation Program across the African region. This includes several countries like South Africa, Kenya, Nigeria, Ghana, and many more. With over 17 years of experience in the financial sector, Lenore has helped many clients certify their buildings and access green finance. Her background includes pivotal roles in building, property finance, and asset management for development impact funds at Old Mutual Alternative Investments, where she championed various green building initiatives. We also have Li Hui, who is the chief architect at China IPPR International Engineering Corporation Limited and chartered architect in China. He serves as an expert consultant for hospital construction and management at the National Health Commission and is vice president of the Hospital Building and Equipment branch within the China Association of Medical Equipment. With over 2 decades specializing in healthcare architecture, he has led the design of more than 80 hospital projects, earning over 40 international, national, and provincial design awards. He was leading the architectural design and implementation of the Levy Mwanawasa Hospital expansion project in Lusaka, Zambia, which was financially supported by China Aid. He has also participated in the Victoria Hospital expansion project in Mauritius. So a warm welcome to our panelists, and we look forward to your presentation. Today, we are turning our attention to the how we take all this knowledge from this week and actually implement it on the ground. We'll be diving into real-world examples and practical strategies for putting building energy efficiency into action. We'll begin with Session 1, which introduces integrated building performance design for green buildings. This session will cover technical requirements and cost technology trade-offs in certification schemes like LEED and BREEAM, as well as energy and water efficiency standards. We'll also explore design methodologies and a case study highlighting the use of modeling tools and monitoring and evaluation outcomes. Session 2 will focus on implementation examples of the IFC's EDGE Green Building Tool and BRI, the Building Resilience Platform. Through case studies from Zambia and Mauritius, we'll see how these tools are being applied to support sustainable construction and climate resilience. Finally, Session 3 will take a closer look at flagship implementation example, the green building design and construction of the Levy Mwanawasa Hospital expansion project in Lusaka. This case illustrates how principles of green design are being translated into impactful infrastructure on the ground. Together, these sessions aim to provide a comprehensive look at both the theory and practice of green and resilient building design in emerging urban contexts. Our hope is by the end of today, you will walk away with concrete ideas and actionable insights, things you can take back and use in your own context. So thank you again, panelists who are joining us today, and we look forward to another productive, engaging, and inspiring day. On that note, let's get started. And Zhuolun, you have the floor.
Thank you, Trupti, for your kind introduction and setting the stage. Now I'm going to share my screen. Yeah, thank you, Trupti, and then welcome everyone to join this e-training program. I hope that this program can give you some insights on how to implement green building in terms of energy efficiency, water efficiency, and then also how to consider different components in green buildings, and then how we can use simulation softwares to combine all these components and then to achieve cost-effective on the investment. So here actually here is my topic: integrated building performance design for green buildings. So I believe that in the past few days actually you already walked through the basic idea of energy efficiency and then the policy essential. But here actually I would like to highlight some of the results why do we need green buildings. Actually, you can see this is one of the report that published in 2021. In 2022 from UNEP Global ABC Global Alliance for Buildings and Construction, and then in that report actually it compare different components or the life cycle costs of green building or buildings and construction globally, and then it also compare the difference between 2015 and 2021, and then also, as you know, that we have a new one which established I think a few months back for the most updated numbers, but as you can see here. First of all, more emerging economics increase the use of fossil fuel gases in buildings. As a result, buildings energy demand increased by around 4% from 2022. The largest increase in the last 10 years. CO2 emissions from buildings operations have reached an all-time high of around 10 gigaton of CO2, around a 5% increase from 2022 and 2% higher than the previous peak in 2019. And so as a result, actually, the report suggests several steps that we need to improve the CO2 emissions in the building sector in order to transit to a future of no carbon buildings. It requires the design of multi-beneficial material strategies that take a whole building life cycle and a systematic thinking approach. So here actually that is what very much in align with today's topic in my presentation about the integrating building performance design. Actually, it requires the systematic thinking, not only thinking of the design, but also covering in the scope of the building, standalone building itself, but also the community and the city scale. And then also not only the architecture design itself, but also the mechanical design, the water efficiency, the energy efficiency, essential. So, and then also, as you may already know, so there are a lot of benefits from the green buildings and implementation, and then also there's a lot of co-benefit as well. So as you can see on the middle button, actually that is from US Green Building Council, a research from them mainly in the USA continent, saying that by implementing LEED certified buildings, and then by operating them in a LEED certified way, actually you can save around 30% averagely energy, and then you can, more importantly, you can save 35% of carbon, and then 30 to 50% of water, and then also you can generate less 50% or even 90% of the waste. So here actually give you some benefit or co-benefits that the green building can bring in. And then also talk about energy efficiency, how it linked with green building. Actually, as you know, that energy efficiency and water efficiency is one of the key parts of the green building certification. And then, like I mentioned, the energy, by improving the energy efficiency in buildings, actually it's not only can bring benefits in the scope of the building scale, but also have the district scale, meaning that if a community, actually all the buildings have this design based on green green building, and then they can have this regional benefits. And then also, even if in the city level, actually it can bring in additional benefits for the city scale. So it can be more environmental friendly, and then conserve natural resources like water and energy, generate less waste and pollution, and then also, more importantly, they can save costs by through using less water and energy. And then, more importantly, actually it can improve the indoor environment with more safer and higher comfortable environment, so that it can improve the health conditions for the occupancy. So then we come back to the basic question: what kind of buildings can be called as green building? Actually, this is not a simple question to answer. So actually, through the past 30 or 20 or even long time, actually there's a lot of discussion on what kind of buildings should be called. So in the past, actually, the original one is make the building green. So this is the original concept of the green building. Here, actually, you can see that make the building all green, and then they call it green building, I think like 50 years ago, something like that. And then later, they say that no, the painting the building in green is not sufficient. So that they say that, every occupants in the building, when they look outside of the building, they can look green. So then they plant trees in different levels, and then on every window of the building, and then they say it look out, and then it's all green. But then, more importantly, actually, in I think last 20 to 30 years, actually they have some concept is like, green building is not a building only, it's a system. with water, energy, waste management, air pollution or IAQ essential, and then it can have different, landmark. For example, in this picture I show here, actually they can have PV panels, they can have high energy efficient appliances, and then they can have high water efficient in the bathroom, essential. So actually, as the time comes by, actually there's more and more components, more and more contents were put into the concept of green building. For example, smart control, AI, essential. So it make the building not only more green, much greener, but also more environmental friendly, lower carbon consumption in the not only in the design stage, but in the operation and maintenance stage, and then have a higher quality of indoor environment essential. So the concept of green buildings are evolving as the time come by, and then now it more and more contents, like I mentioned, is put into this concept. So, but in general, so why we call it as a green building, and then look at this current current green building rating systems. Actually, first of all, they would do it not only in the design stage, but they would look at the whole building life cycle, including the transportation of the material for the construction purpose, the design, of course, urban planning, landscaping, and then also the indoor indoor environment operation and maintenance. So actually you can see from here, actually it is a status from the US Green Building Council, and then they outline the most important components to be considered when they say it is a green building. And then actually you can see that actually it can cover, like I mentioned, urban planning, architecture, design, construction, which is on the left side of the circle. And then they also have considered, the components of operation and maintenance, OMM. And then you can see that even for the OMM stage, actually they have different weighting factor, meaning different, importance, on different components. For example, efficiency, local economic, education, essential. So nowadays, the green building, like I mentioned, it is not only a building itself; it's becoming a complicated system and covering, different components. And then also, but when we look at a green building as an example, and then we can see that okay, they normally have different types of efficient system that can make the building green, let's put it that way. And then you can see that, for example, in the left side actually is a typical green building in Colorado, USA back in 2023, I think. And then they consider, okay, whenever you call your building as a green building, you need to consider all these components, which is quite adaptive to the context of the local weather status, and also economy and also culture. And then on the right side, actually, nowadays in some of the countries, including some African countries like Tunisia, Egypt, and the MENA region, actually they are extending the green building concept from the standalone building to a city, a city or regional level. So they combine it as the green building clusters to the sustainable infrastructure. So then they compare in the city level or the regional level, which make the standalone building to achieve the requirement of green building much easier, and then also much more cost effective. So as you can see here, actually they can, for example, the city government can have the centralized, for example, wastewater treatment and recycle system, which will in turn that help the end user buildings, to connect the wastewater, to treat it, and then also to recycle and reuse it. And then the cost can be as low as 30 to 40%. So this is an example. And then also, as you can see, that there's a lot of green building rating or certification system in the world, and then of course some of the developed countries like USA, like UK, actually they have this lead and green system for many years, like in Germany also the DGNB system, and then also some of the developing countries, they also have their own green building certification system. For example, China, for example, I know South Africa, and etc. So here actually I summarize some of the green building certification, and then I think that today one of the panelists from IFC, Lenore, will talk about their EDGE and BRI system, which is promoting and developed by the World Bank Group. And then they have different focus, of course, for different certification systems. And then also for example, normally all the green building rating system, actually they have different levels from the certification level. For example, LEED, they have certification, Silver, Gold, and Platinum. So they have different levels, and then they mean that they can the higher level you are achieving, that means that you can have a higher level of energy efficiency, water efficiency, indoor air quality, and etc. But the basic idea here is that we cannot say that, okay, one program can work for all buildings or projects. The design team need to look at each program carefully to determine what is best for the project. And then also, different programs have different focus in terms of weather conditions, costs, and then also, regional or local cultural differences. So when we select the different green building rating systems, actually we need to consider this. There's not right to say that one system is better than the other. That's not right, but it's like more suitable. Let's put it that way. And then also there's some some statistics to summarize, okay, where the LEED system it is. For example, the LEED system have different categories that fits different types of buildings. For example, they have a neighborhood development, they have new buildings, they have campus buildings, data centers, etc. So they have different categories which can fit in different buildings. And then also they have different chapters which you can get points with different focus. For example, they have the sites, they have the water, energy, material, essential. So it's all summarized here. Considering the time, I don't want to go deep into it. And then also, like I mentioned, they have different, like for example, the LEED system. They have like homes, neighborhood, and the neighborhood developments, operation, new BD and C. It's the new development. Yeah, and then they have different levels, and then with different points. So this is the basic LEED system. And then some of the other green building rating system, they have very similar. You get the points, and then you can see that, okay, which certification levels you are once you calculate all the points. So these points, it's based on different categories, essential. So here, and then also we have a very quick comparison, or just a quick comparison between the China's 3-star green building rating criteria and weighting factor with the LEED rating criteria and weighting factor. Actually, both of the system, and then I think all of the rating system almost, actually they consider similar categories, but the difference is the weighting factor here, how many points for each category you can get, and then how much how different the weighting factor it will be looks like. So this is just an example to show you the difference. And then, like I mentioned, there's a lot of co-benefits by implementing energy efficiency in green buildings and other perspective. So here, actually, I give you just a quick example of the co-benefits that are between the health and energy efficiency. So I don't want to go too very detailed into it, but basically, for example, in order to have higher efficiency, probably you need to have a better insulation, and then also need to require the window have a higher air ceiling level, and then that means that as a result, that there will be like warmer, drier, lighter air indoor, and then they will improve, the indoor temperature and also relative humidity, and then it will bring in better, some co-benefit for the health, consideration by like, okay, fewer heat or cold related death, less heart disease, etc. So actually, there's a lot of research already done, and then also ongoing, especially after the COVID period. Actually, this health and energy efficiency, this co-benefit are become a hotspot, and then there are a lot of people working on that, doing a lot of researches and studies. So here, just give you an example. And then also, go back to our topic, about the integrated building performance design process. Actually, normally this building performance design process will follow the normal design process, but they need to consider other things. For example, to start, actually, you need to understand better the local climate. What kind of potential energy efficiency and water efficiency can be achieved under the climate conditions. So the first step, instead of just to do the site analysis as the normal architecture design process, actually we normally will think about the climate condition of the local spot, and then we go to once we have the idea of what kind of potential energy efficiency can be achieved, what kind of energy conservation measurements, ECMs, can be embedded, and then we start from the site analysis, and then with an eye open to the potential, implementation of these ECMs from the site analysis level. For example, there's some ECMs by, planting trees in the right place with the right trees, and then when we do the site analysis, actually we need to consider the landscaping perspective already, and then we go to the design, concept development, and then to think about, okay, how to integrate, these ECMs, for example, how to change the window to wall ratio, how to optimize the orientation of the buildings, essential, and then we can go through that to material selection, and then to think about, okay, what kind of material that they have less embedded carbon footprint there, and then also whether we use this material, whether it will impact the indoor air quality, and then we can go to, once we do the selection of the material, and then we go to the energy analysis. That's normally when we use huge workload on the energy simulation on that regard, to help the architects and also urban planners to improve or optimize their architecture design, and then also water efficiency, and then but like I mentioned, green building it's not just like one person do it. Actually, they need to have a teamwork. So we need to listen to the feedback from different engineers, and then also probably building owners and occupants. I mean, not too early to say occupants, but mainly building owners, and then different stakeholders, for example, from the government, essential, and then we can have feedbacks and then improve our design, and also the cost analysis also, and then also, more importantly, the green building, normally they will require the feedback from the building management team, so as to how to better operate and manage the building once it is implemented, and then we have this design. But But by saying that, actually, how to start? Actually, this is some example that we did for Mauritius and Zambia. For Mauritius, like Trupti mentioned, the GPUC program selected Port Louis as the pilot city, and then for Zambia, we selected Lusaka. So by looking at the climate data, the TMY data for the past 20 years in both cities, mainly from the international airport, we can see that, okay, what kind of technology can be used to, one is to save energy, second, more importantly, to assure the indoor thermal comfort level under the ASHRAE, ASHRAE, standard. So by this, actually, before we start the design, actually the architects and then the other engineers can have a basic concept. Okay, what to do, what should be considered in the architectural design, and then also that one furthermore. So for example, in Zambia, this is the software developed by our strategic partner, Germany Energy Agency, DINA, by actually Mr. Tilu. And then he kindly shared with me this CO2 saving potential analysis in Zambia. Actually, they do, like in the very top. Actually, he defined the climate in Zambia into whether it is extreme hot or extreme cold, and then what type of climate it is in different Zambia cities. As you can see there, he analyzed 6 cities, and then each city they define the climate condition, and then based on that, actually he can outline or suggest some of the CO2 saving technology regarding the renewable energy efficiency, gray energy, essential. And then so before the architect can design the building, actually they can already have a basic idea what to look for. And then here actually is an example that I worked together with Foster and Partners when I was in USA. Actually, it is designed for sun. So this is an apartment for all people, and then the architect require that they need to have at least 8 hours of sunshine every day. 6 hours. 6 hours every day, and then we help the architects by through doing this sunshine simulation to cut down the different shapes of the building. So then we reach the final design plan as the right side. And then with this special shape, so that the sunshine can come in not only in the morning but also in the afternoon. So then back to the topic. Okay, we need to understand the climate better, and then so as to find the potential energy saving as climate adaptive purpose. So in Zambia and Mauritius, we did the analysis, and then we've outlined, there's like 6, potential, ECM energy conservation measures that you can use. And then as you can see from the left picture, actually, the more on the left is more on artificial, meaning that you need to have electricity, you need to have man-made material to be installed in the building, and then whenever you go to the right side, it's more closer to the natural or passive. So then, for example, by planting trees, by using reflective materials like pole roof, essential, actually it can help you to already naturally reduce or passively reduce the energy consumption. So you can see here, and then also on the right side a feature, actually in terms of the natural ventilation, actually we analyze the climate of Zambia and Mauritius, and then outline, okay, they need to follow follow the following categories, so that to improve from the low ventilation to high ventilation possibilities. And then actually maybe you don't maybe the people in Zambia and Mauritius actually you don't notice, but actually you are already using some of the technology that I mentioned before. For example, the external shading. So the left side is the picture I took in, I think, University of Zambia when I visited there last year, and then it's already have this external shading, for the pedestrians, and then it works quite well. And then the same thing, in Port Louis, we have they have this shading, on the building, and then also on the facade as well, as you can see on the right side of the feature. And then also, they have the building integrated shading in the building. They have the heavy massive wall, and then they also have the ventilation enhancement, on the building envelope. On the left side, again, it is the picture that I took from some of the university campus buildings in Lusaka. And then on the right side, actually, is in Port Louis in the Chinatown, basically. But you can see that they are considering similar things: external shading, and then also, that use this ventilation enhancement in design in the facade, in the walls, and then also using heavy massive walls, to reduce the indoor temperature, fluctuations. So this is what I see. But then we need to think about more things, about more components. So then we think about, okay, so what exactly we should do in the integrating, building performance design. And then like I mentioned before, it is not only the standalone building itself, but also the community level. So actually, this is the picture that we took in the hot summer day, I think in the middle of June, in the hot and humid climate. And then you can see that actually by the pavement, actually, if you use cement in the pavement, actually the heat in the summer is very high, the temperature. But compared to the grass ground, nearby, actually the temperature can be as high as, the difference of the temperature can be as high as 10 degrees C. So then you can see that, okay, we come to the conclusion, okay, we need to plant trees, but how we should plant the trees? So we need to consider the outdoor thermal environment. So here actually is also an example. If the wind direction in the summer is from south to north, as you can see here, so it doesn't make sense to have all the high trees planted in front of the building, because they will block all the natural ventilation, so that the building cannot benefit for the cold air temperature. So the normal way we should do is to plant the high trees behind the buildings, so then the cold temperature wind can go from the outside, can go through the building and then reduce the air temperature. So here actually also what is the impact of the vegetation rates to impact on the cooling, electricity. We do this study based on Guangzhou city in China, which I believe have the similar high temperature in summer, similar to Mauritius and Zambia in summer. And then we find that, okay, so it's not saying that, okay, the more trees you're planting, and then the better. The best, vegetation ratio is 55%, because you can see that there's a high drop of cooling electricity consumption from 35% to 55%. But if you increase that, and then the cooling electricity will not increase that much. So, and then also, what is the distance from the building to the tree, and then what is the best distance? So we do this simulation also. And then also the wind environment, like I mentioned, we need to consider not only the summer but also the winter. And then it will cover the comfortable level to the dangerous or safety level. So here actually is some of the simulation we did from the wind safety in winter, and then also considering the wind comfort in summer. So this is the community level. And then also you will ask, okay, what kind of simulation or tools that we can use? So I summarize some of the tools that we can use here for different purposes. For example, the simulation tools to integrate different, performance, actually Ecotech like Design Builder, IES, that would be the normal, tools. And then for the environment, normally it is the CFD tools like Fluent or Phoenix. And then for the building energy simulation tools, that would be eQuest and Energy Plus. And then also there's as the time, as the technology improve, or moving forward, actually there's a lot of tools, new tools are coming out. It's called BIM based tools like Autodesk Insight 360 Essential. So here actually considering the time, I go through a very quick design case. So here is a design that we did for the social housing, using different types of simulation tools to make sure it is covering the thermal comfort and energy efficiency for the green building certification. It is like a long land, and then with 10 buildings, high-rising buildings for low income and middle income, families. And then we found that it's very difficult at that time because they have a big sunshine, they have a difficult, wind or natural ventilation if we follow the normal, design, strategy. So we decided to change it together with the architect and urban planning and also the landscaping, engineers together. And then on the left side, it is how it looked like when the design looked like, and then on the right side, actually it was constructed, and then it's how it looked like right now. So basically what we do is that we do the sunshine simulation for summer and make sure that we block the sun, by using different shapes of the building. Like why we have this S shape of the buildings is that we need to use the building to cover to use the building shadow to cover each other. And then we also need to make sure that in the winter there's sufficient, sunshine can, get into the building. So this is the final result, but actually we do quite a lot of simulation doing the architecture design. And then we also need to think about, okay, in winter, which rooms should locate it in where. So make sure that each rooms have a sufficient sunshine hours. And then also we do the wind environment simulation in winter. So here actually, as you can see from the cartoon, actually we see that whether in the winter whether the wind speed are too high or too high considering the safety. So then we need to improve the architecture design, if that's too dangerous. And then also in the summer, we do this simulation to see that, okay, whether there's too low wind speed so that it's impossible to have natural ventilation. So by doing this, actually, we need to facilitate the building design, the floor plan design to make sure that we have sufficient window, operator window, and then to make sure that the wind can go through outside to inside to reduce the indoor air temperature, and then that's to reduce the electricity, the cooling electricity consumption for air conditioning. So here is some of the result. And then the final slides from my side is that I have three conclusions. So first of all, green building requires to have a systematic thinking. So it will cover different, design stage and then also the operation stage. So from planning, landscaping, architecture and MEP, mechanical design, construction, commissioning, operation, and maintenance. And then you need to consider not only the health, energy, water efficiency, but also the cost effectiveness. And then also the health and efficiency, like I mentioned, are the two important features that can bring in co-benefits to each other. And yes, so with that, I think that I finish my presentation here, and I hand over back to Trupti.
Thank you, Zhuolun, for diving deep into the concepts of green buildings and for mentioning all the design strategies that that architects need to keep in mind in the design phase. And now it's time to learn from Lenore about the EDGE tool as well as the BRI tool developed by the World Bank EDGE team. So over to you, Lenore. You have the floor.
Thanks, Trupti. Thanks, Zhuolun, for that great coverage of what green building design is all about and the different factors that are important to take into account. I think that gives a great link to what I'll be covering today, which is around the EDGE green building certification, as well as the Building Resilience Index tools. So IFC has an holistic approach to climate mitigation and adaptation in the built environment, and today I'll be covering two of the tools. The first one is the EDGE Green Building Certification System. EDGE stands for Excellence in Design for Greater Efficiency. And this program started in 2015. So this year we celebrate 10 years of EDGE certification globally. And in Africa, we started in South Africa and then grew across the continent to various countries, including Zambia and Mauritius. We also have the, so EDGE is on the mitigation side, then we have the Building Resilience Index, which is a verification system for resilience in buildings. It's on the adaptation side, and this is a newer tool. We've had it for the last 2 years, so it's still growing, and we're still establishing that program across Africa. We also have the APEX Green Cities, which is around greenhouse gas reductions and green investment planning for cities. That's on the mitigation side. So what is the role that buildings can play in climate change? On the one hand, we have green buildings that connect with the EDGE tool. So we've had a great introduction from Zhuolun around buildings and climate change. So buildings, they produce about 40% of global greenhouse gas emissions from energy use every year, and this contributes to climate change. Because of the climate change, we have more and frequent and more severe climate hazards. So to address both of these aspects, we have the green building tool for EDGE, which is around 3% additional cost for going green. And generally speaking, we have a payback period between 2 and 3 years. And on the other hand, we have the Building Resilience Index. For every $1 US dollar that's invested, we can save $4 US dollars in terms of preventing some of the effects of the climate hazards. So following IFC's track record on buildings, we started with the climate change mitigation using EDGE, and then BRI complemented by addressing climate change adaptation. So why was EDGE created? So there are many different green building standards, as you've heard. The reason EDGE was created was to mainstream green buildings and to tackle climate change. What we saw in the market, that there were many green building standards that were focusing more on the high end and they involved a higher cost as well as many different components that you needed to achieve in order to meet the standard. So most of them were focused on that top tier, that top triangle there, which was custom buildings, and they provided leadership. They showed that they were leading the change in terms of green buildings, but it was difficult to implement those standards on, like, for example, affordable housing or social housing, and that's where EDGE was came in to be able to address that particular gap in the market. So EDGE was created to mainstream the resource-efficient buildings in emerging markets. So why EDGE? It's got international acclaim. It also helps for clients to be able to link to green finance. Often, if we want to be able to have green investments, there are many investors who want to invest in green buildings. You have to be able to demonstrate that the building is actually green. So I will go through some of the ways that EDGE aligns with various international standards so that it can be acceptable for the use of proceeds in different ways and for green finance. It's also got a cost calculator. So EDGE helps you decide the best green options and to estimate incremental costs for going green. In some cases, that can be even less than 2%. There's often a perception that green buildings are very expensive. Some people perceive it to be 20% or 30% more expensive than a normal building, but in fact, that cost can be reduced, and we've even seen it down to less than 1% for some clients when they've actually they've gone through the different green building measures, they've optimized it, and they'll be able to bring that cost right down. EDGE focuses on resource efficiency, energy, water, and embodied energy in the materials. It also uses bioclimatic modeling. So even though it's a global standard, it does take into account the local climatic conditions of the country where your project is. We've done our best to streamline the process so that we have a shorter workflow for certification that saves time, and also to have efficiency in terms of the required documentation. And it helps clients to decarbonize their portfolio. So there are three aspects to EDGE. One is the free software. We have a web-based application that anyone can access. If you go to edgebuildings.com, you can access it there, and you can put in your building design and quickly assess whether it's able to meet the standard. It's an achievable standard. There are only three measures that we take into account: energy, water, and embodied carbon within the building materials. And we use the local baseline, whatever that may be in the country where you're operating. We use the national building code in that country. And in order to achieve the first level, you only need to be 20% more efficient in energy, water, and in the building materials. And then there's also the certification part, whereby you receive a green certificate. We have various certifiers. We have 4 operating across Africa, 3 global certifiers, and 1 Green Building Council of South Africa that's specifically Africa-based. And they would then certify that that building is green. As I mentioned, we have the free software that's web-based. It also helps you to look at the return on investment for different measures. So you'll see there's a dashboard when you go into the software. And these are some of the measures that you can look at on that dashboard. The first 3 are the energy, water, and the building materials. It shows you how efficient, what additional savings implementing those measures that you've chosen would bring you. So it helps you to be able to make choices. It also shows you the utility cost reduction, what the incremental cost of those particular measures that you've chosen is, and then based on the utility bill savings, what the payback period would be. So for example, if you use certain energy or water savings or material savings, those will give you savings within your energy and water savings, will give you savings on your utility bills, and that will be offset whatever incremental costs you would need to incur in order to implement those particular measures. So that will then help you to assess the economic viability of the particular measures that you're choosing. Often developers and designers are looking at, yes, they would like to implement various green measures, but is there a budget for it? And how can they make choices about different elements in order to see what would best suit the budget, but while still meeting the standard? So all of that can be calculated within the Edge app. It shows you, as I mentioned, the construction cost, the utility savings, and the payback period. It also shows you the embodied energy savings, water savings, and material savings. So what that then helps is if you need to report on the kinds of climate improvements that you're making on your buildings, then you can bring in these calculations, what's already generated by the report on what the predicted savings will be from implementing those green building measures. It helps with carbon tracking as well, gives you the operational CO2 savings, as well as the carbon emissions in terms of tons of CO2 saved per year. So as you're looking on the left-hand side, you'll see there are various green building measures that you can implement. For example, this is on the energy saving side, and this particular example is for apartments. You'll see there window-to-wall ratio, reflective roof, reflective exterior walls, and so on. So each of these measures, whichever one you choose, will then be reflected here on the improved case. You'll see the base case is the current building without any improvements, and then you'll see the improved case. As you implement various measures on the left-hand side, you'll see the improved case. This will come down. And depending on which measures you use, you'll see there's also color coding associated with different types of measures that you implement. And ultimately, you'd want to reach at least 20% savings on the energy. So in this way, as you're choosing different options, you'll see what the final energy uses, the water uses, the embodied carbon. And if you click over to the right, you'll also see what that incremental cost is of that particular measure, as well as the utility savings. So in that way, it really helps designers to make informed decisions about which measures they will take to improve the building to reach the EDGE standard, to improve the building performance. But it also shows you what the cost associated is with each of those decisions. And then the team, as Zhuolun spoke about, it's a team-making decision. So then the team can decide which would be the most appropriate measures that they would like to have for that particular building. As I mentioned before, it takes into account bioclimatic data. So depending on where the project is located, it will bring up the data associated with that. There's growing evidence that EDGE certification also can increase profitability of projects. We've seen that, for example, in housing projects, if the project is shown to be green certified, sometimes there is a higher uptake of the tenants coming to rent those particular green apartments. We've also seen in sales where EDGE certified apartments sold faster than non-EDGE ones for the same client. We've also had examples of where clients have been able to demonstrate that if you rent a certified building, or a building that is more resource efficient, then they could save renters up to 1 month's rental in a 12-month period, and that they would then use that for their marketing. And so having a green building is not just better for the environment, but it can also improve the business case and can be increase profitability. So these are some of the other ways, like, for example, quicker sales. They could also differentiate their product in the market. There's also an opportunity to have a green portfolio. And we've also had clients where they built a number of green assets together, and then they could have a green bond and go out into the market and get investments for that particular portfolio. So EDGE can certify across all building types, and it's available globally. We've certified hospitals, industrial buildings, offices, homes. Housing and homes are one of the top categories across Africa because there's a huge housing shortage across the continent. And housing is definitely also an issue for Mauritius and Zambia. We've also certified education buildings, hospitality, various hotels, service departments, warehouses, retail, shopping malls, supermarkets, and even airports. So there are 3 levels to EDGE. There is the first level where the project needs to be 20% more efficient, or the building needs to be 20% more efficient in energy, water, and embodied carbon in the materials. For EDGE level 2, it needs to be 40% more efficient in energy savings. And then level 3, or zero carbon, it needs to be 100%, all of the energy required for the building needs to be produced on-site, or they could purchase carbon offsets. So in all of these cases, EDGE compares your green building to the locally relevant conventional building. Excuse me. So whichever country you're operating in, as I mentioned, that will be the local building code. So there are various advantages of EDGE for home builders, commercial owners, and those who are building to sell. And there are 3 steps within the certification process. The first step is to register the project within the EDGE app. The second step is to, once the project has been registered, then they need to upload the documentation. And then that will go through the certification process. It also needs to be validated, and there is an auditing process. And I'll show a little bit more detail on this. So once the project is registered, it can be, there's a design audit, which the EDGE auditor will go through the documentation and check that it does actually meet the standard. And at that stage, they receive a preliminary certificate. So basically, that's a design certification. Then once construction happens, an EDGE auditor would go out on site to check that what has been constructed still meets the standard. And then at that stage, you'll get a final certification. If you're going for zero carbon, then there needs to be 1 year of operational data in order to demonstrate that whatever energy is needed for the building is actually being produced on site or being offset through carbon offsets. So there are various roles on the EDGE project. You have an EDGE expert and an EDGE auditor, as I mentioned. When the project is registered, then the client can develop a certification strategy. The documentation is collected in the design stage and then uploaded. Everything happens in the EDGE app, which is web-based, and all of the data is then stored in the cloud, all of the documentation. During construction, the documentation is collected, and then the site audit is conducted. And then for for the zero carbon, the operational data is also collected. So the edge expert basically helps the client through the certification process and ensures that all the documentation gets uploaded appropriately. The edge auditor will then review the documents at design stage and then at final certification stage, and then we'll submit that to the certifier. The certifier will review what has been submitted, and then they will either grant the certificate, or if certain documentation is missing, then we'll ask the edge expert to fill those gaps. So it's possible to become an edge expert by doing a one-day training and then going ahead to do an exam, and then one would get an accreditation to be able to take clients through the edge certification process. On our website, we've got lists of hundreds or thousands of edge experts around the world. An edge expert can operate in any country, but edge auditors are specific to the different certifiers. So each certifier will have a list of their accredited auditors who are edge experts, but they've also gone through a special training with the certifier in order to become an auditor for them, because each certifier has their own processes. So across Africa, we have four certifiers. We have the Green Building Council of South Africa, and then we have GBCI, and we have Centali and Bureau Veritas. GBCI, Centali, and Bureau Veritas are all certifiers. So they can all certify in Zambia and also Mauritius. So these are some case studies from Mauritius. This is a mixed-use office and retail project that achieved 37% in energy savings, 33% water, and 41% in less embodied carbon in the materials. And these are some of the measures that they implemented: reduced window-to-wall ratio, reflective paint in the or the tiles for the roof, low E coated glass, and then you'll see they've got energy-saving light bulbs in the internal spaces and external spaces, and then lighting controls for corridors, as well as occupancy sensors. On the water side, they have implemented low-flow faucets in the bathroom, energy-efficient flush for the water closets and the urinals, as well as water-efficient faucets for the kitchen sinks. And on the building materials, floor slabs, roof construction, external walls, internal walls, flooring, and window frames, they used energy-efficient materials, or materials with lower embodied carbon. So you'll see that most of those measures are not, they are achievable, and that is part of what we've been trying to demonstrate with the EDGE certification, is that green buildings are achievable, and they're often much closer to the project design than one might think. Sometimes just a few measures here and there that need to be tweaked, and then you can achieve the standard. And the next is also Boplan. This is block 3. Similar energy efficient measures were implemented, and in this case they achieved 40% energy savings, 33% water savings, and 41% less embodied carbon in the materials. And in this case, you'll see they didn't actually, often there's a perception that you have to have solar PV in order to have an energy efficient building, but you'll see that they achieved this through the measures listed here. In Zambia, we have a case study of Standard Tower. This is an office building. They achieved 50% savings in energy, 55% in water, and 34% less embodied energy in the materials. They also use reduced window-to-wall ratio, some insulation of the roof, higher thermal performance glass, variable refrigerant VRV cooling system, energy savings in the lighting in internal and external areas. They also used occupancy sensors and in this case, they do have solar PV providing 15% of the electricity use. And for water, they have low flow faucets in the bathrooms, energy efficient flushing for the water closets, and water efficient urinals and faucets for the kitchen sinks. And you'll see there listed the various materials for the concrete in situ reinforced concrete slab. All of these help them to reach the 34%. And then this was actually the first certification that we had in Zambia, which is the Novare Great North shopping mall. And this achieved 46% energy savings, 47% water savings, and 30% less embodied energy in the materials. And here we also see a reduced window-to-wall ratio, reflective paint or tiles for the roof, insulation of the roof, VRF cooling system, and energy-saving lighting. For the water, dual flush water closets, water-efficient urinals and faucets, and aerators and auto shutter faucets. For the materials, steel, zinc, or galvanized iron, and sheets or rafters. And it's possible to do retrofits. I'm just going to speed up a bit so that I can cover the BRI. This is a retrofit housing project in South Africa, just as an example. So IFC's definition of a resilient building is a building that can withstand the hazards it's exposed to today and tomorrow due to climate change, and ideally continue its operations without disruption following an intense hazard event. So there are three different aspects. It's identifying the risk, managing the risk, and disclosing the risk. BRI is online and globally available to users free of charge. And as of November last year, we had 168 projects, resulting in 9.3 million square meters of assessed total floor space and $5.6 billion in total asset value. And BRI is growing. So what is Building Resilience Index, BRI? It's a verified self-assessment online application that rates any building's hazards mitigation measures. And in identifying risk, a local specific and asset focused approach is used. We've used historic data on natural hazards and future-looking climate change projections. And these are some of the aspects that we've taken into account: wind, water, fire, and geoseismic hazards. In terms of managing the risk, new buildings and retrofitting existing buildings, this is some of the way that we would manage the risks, and these are various building types. Some of the resilience measures are site selection, foundation design, structural design, building services, material selection, landscape and site design, and construction audits. Sorry. So we have a disclosure risk, and there's a standardized rating system. And this goes through various measures. On the left-hand side, this is when the building fails to incorporate the most recommended resilience measures of BRI, and then we have B, which is between 30 and 50%. It incorporates some recommended resilience measures. So NR means non-resilient. Then we have A plus, which is between 10 to 30%. It incorporates the most recommended resilience measures. And AA plus, which is 5 to 15% plus, it incorporates all of the recommended resilience measures. So whenever you're looking at a site, you can put that site into the BRI, and it will then make these calculations, and you can see if there's a site close by that you might choose. If you're not able to meet the rating, you can see if there's a site close by that would be a better site, or look at various mitigation measures that you could do to improve the rating of that particular site. And there's a weakest link principle. It uses the applicable local hazards that must be addressed in order to achieve the overall resilience. And the building resilience rating cannot be higher than the weakest link, which is any relevant hazards. So depending on which hazards are being taken into account, whether it's wind, water, fire, or geo, you'll be able to, if they're all yes, then you would get a B. But if you have one, if you have a non-resilient, then you would get a non-resilient for the building. We have we're just in the process of training verifiers, and we're having the first verifiers getting certified. So in this process, we've just trained a number from Mozambique as well as from South Africa, and we're still coming to Mauritius and Zambia. So for now, we don't have local verifiers, but we're in the process of training them up so that they can then, once the client has done a self-assessment, they would be able to then verify the rating that has been achieved. And these are ways to benefit from the BRI. We have construction developers, banks, insurance companies, governments, property buyers and owners, as well as occupants and lessors. And these are the various benefits that they could have from achieving BRI. And so we have one case study in Mozambique, and this was the first Sub-Saharan Africa to implement BRI. We've had early adopters that are under self-assessment for reconstruction and rehabilitation of health units. We had community health, UNDP. We've also had resilient project Gorongosa National Park and UNICEF Maputo office building that achieved Edge Advanced. So we had the first verifier training in 2024, and there were 5 verifiers that have been certified in Mozambique, and we launched the first green resilient building professional network in Mozambique called the Bridge Cafe. So far we don't have any BRI buildings that have been certified in Mozambique or Zambia. As I said, we're still in the early stages, and that's all from me.
Thanks, Lenore, for going over the EDGE tool and also for bringing our attention to the Building Resilience Index tool as well. I think it can be easily overlooked. So thanks again for your excellent presentation. And now to learn more about the Levy Mwanawasa expansion project in Zambia, I would like to invite Mr. Li Hui to present based on his learnings from the project. So Li Hui, you have the floor.
Hello everyone, glad to have chance to join this webinar. I'm Li Hui from China IPPR, International Engineering Corporation Limited, and there are 2 colleagues with me, Ms. Zheng Jia and Mr. Zhuang Zefeng. My topic today is modern green hospital design in the context of local culture environment. The case of Levy Mwanawasa University Teaching Hospital, Zambia. During the past 70 years, IPPR undertook a large amount of medical facilities design and construction worldwide. Most of the projects locate in Southeast Asia, Africa, and Central America. The project of Levy Mwanawasa University Teaching Hospital is a China aid project. The construction included two parts. One part was a new construction of 690 beds general hospital. The other was the renewal of the existing hospital with 136 inpatient beds into a maternal and children medical center. The hospital is located in Lusaka, the capital city of Zambia.
Hello, Trupti. Can you see the second slide of the PPT?
Yes, I see the introduction.
But do you see the hospital?
The slide with the picture of the hospital, the bird's eye view, right? Yes, yes.
Yes. Okay.
Okay, good.
Okay.
Yes. And this picture is the perspective rendering of the whole project in 2015. This photography is the overview of the hospital in 2023. And this is the rendering of the outpatient building. This is the real scene of the outpatient building. This is a design rendering of the inpatient buildings with 3 ward towers. This is the real scene of the inpatient buildings. And this is a design sketch of main entrance space of the outpatient department. This is the actual space of the entrance. Plenty of the preliminary research have been done before the design process. Since there was no second-class general hospital in Lusaka province at that time, a high-level hospital to fill the gap of the medical system for the capital city is in great request. So the aims of building the project were: first, enhance the level of medical services by building the new facilities. Secondly, build a second-class hospital in Lusaka province to supply the lack of local healthcare system. Thirdly, construct a high-level modern general hospital achieved to the first extent standard as Class 3, Grade A, according to Chinese classification of hospitals. Fourthly, this new facility should be built as an advanced, distinctive, harmonious, economical, sustainable, and resilient building. In the feasibility study phase, we worked in Lusaka with the governors, the clients, the medical staffs, and the engineers for months to discuss various aspects of the project. In design phase, the influential facts be taken into consideration included geographic and climatic conditions, local economic developing level, functional mechanism of the healthcare system, lifestyle and cultural habits, and the potential of future development. For green hospital design, reference construction codes included LEED for healthcare, the American standards, and the Green Hospital Building Evaluation Standard, the Chinese standard. Relevant key considerations were sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, operational excellence, and maintenance, durability, etc. Research has shown that the energy consumption level of hospital exceeds twice of that of average public buildings, and the heating, ventilation, air conditioning system, and the lighting system account for the largest proportions in the total energy consumption of hospital. Therefore, the sustainable development of hospital should lay more emphasis on the control of HVAC system energy consumption, lighting energy use, and the medical equipment's energy demand, as well as the efficiency of medical function. For Zambia, a least developed country, climate-responsive building layouts, passive ventilation strategies, daylight optimization, and adaptive shading systems, etc., are the most effective technical measures. On account of this, we proposed the main design concepts as the following. Fully integrate the medical function between old and new buildings. Keep the scope of the renovation project within the 20% of the original. Planning a simple medical functional framework with high efficiency performance. The cardiology specialty unit and the integrated healthcare system achieve synergistic resource sharing. Design a separated infectious diseases unit with hygienic security. The architectural layout should encourage the integration of the inner space and the natural environment. The green strategies responses the regional and the cultural characteristics. This is a site plan of the hospital. For the new constructions, the outpatient department group located at the east side. The emergency department is at the northeast position. The inpatient department, which has 3 ward buildings, lay in the middle. The diagnosis and the treatment department is in the center of the functional plan. The renovation group along the west side were reconstructed into a maternal and children medical center, the administrative and the logistic building, and the support facilities are at the south side. All of the function zones are clear to identified, with no interference and convenient to connect to each other. Different types of personnel are assigned separate entrances and exits. The H-shaped main medical street provided the transportation routes between buildings and creates a high-efficiency functional framework. The routes for sanitation supply, food delivery, and waste transportation are all independent from each other. The picture on the right side shows the effective and hygienic performance between different medical departments. Taking into account the renovation costs and the time saved in construction, keep the scope of the renovation project within the 20% of the original. Balancing the earthwork volume is a good use of site and reduces the cost. The H-shaped main medical street reserves the open connection of the new construction in the future. Based on the geography and the climate condition, we used the computer simulation software to analyze and optimize the light and the airflow for the building's orientation and organization. According to the conclusion of the computer simulated models, the multi-story decentralized building layout not only provide the efficiency of medical function, but also sufficient sunlight spacing between buildings. The architectural shadows from effective shading, creating a relatively favorable microclimate environment for the natural courtyard spaces between buildings. The influence of strong sunlight in Lusaka was considered carefully. The intensity of solar radiation on the building site affects the comfort of outdoor spaces, especially areas with frequent human activities. Computational simulation shows that the solar radiation intensity in the entrance spaces of the outpatient and emergency department and inpatient department, as well as in each courtyard space, is relatively small. Combined with appropriate shading facilities, it meets the requirements of comfort. All-round shading systems were installed on the buildings, which allow more sunlight to enter the rooms in the cold season, while preventing excessive sunlight in hot season. Additionally, vertical and horizontal shading components have the highest shading efficiency in the north-facing walls. Sufficient and well-balanced natural light is provided for the inpatient wards and the consulting rooms, which reduced the artificial light installation and lower the energy consumption. The indoor air environment has been controlled to be fresh and comfortable by installing louvers in windows, doors, walls, and corridors to enhance natural ventilation and airflow convection. Many green technical measures were applied to reduce the energy consumption and water saving, such as solar panel for hot water, natural courtyards collecting rainwater to maintain the balance of groundwater, etc. Sanitary ware such as wash basin are arranged in clusters to reduce the complexity of vertical piping installation, while the water drainage pipes are set along exterior walls for easier maintenance and replacement. All of the public spaces are open to the natural environment, promoting accessibility and orientation of the complicated medical functions. The rampway between the different floors encourage patients to walk voluntarily with attractive view of courtyard scenery. Local social customs and cultures are highly valued. Open pavilion and a small church were designed for patients' families, visitors, and medical staffs. The architectural form of Levy Mwanawasa UTH extracts the aesthetics from vernacular architecture, also combined with classical Chinese architectural elements in a harmonious fusion. Proudly, the Levy Mwanawasa UTH project won the Global Best Healthcare Project by ENR 2021, which is the most famous and authoritative magazine in the field of engineering and construction all over the world. The hospital is not only a successful project, it played a crucial role for saving people's lives and maintaining the medical system during the pandemic of COVID-19. The hospital was operated smoothly, effectively, and safely in the emergency period. For the great achievement, the hospital was upgraded to the Levy Mwanawasa University Teaching Hospital by the Zambia Ministry of Health. Lots of leading technologies and sophisticated procedures could be delivered and practiced in this modern and fully equipped hospital, exerted its effect and contributes for the well-being of people in Lusaka, even throughout the country. Also, the China Aid medical team can work fluently in the environment, which is very friendly and similar to the high-level hospital back in China. Here is another example case of modern green hospital in China, which was designed by our team in 2010. It is a hospital providing highest level of medical services in South area of China. The technical measures used for sustainability were basically same as those used in the Levy Mwanawasa UTH. For example, combined shading systems, sufficient daylight use, and environmental friendly open spaces. The natural air from the sea flows passively across the whole building, while shading systems keeping the hot radiation from entering the inner spaces. The outdoor and indoor environment are of high quality in temperature, humidity, sound, lighting, and viewing. The curtain glass of the outpatient department lounge, equipped with circulating waterfall and electrical shading system, creates a cool and comfortable climate environment for the people inside. Just 3 weeks ago, I visited the hospital again during an academic conference. It looks like a brand new hospital, brimming with life and cultural charm. Here comes my conclusion. For green hospital design in different countries, the core value of the sustainable healthcare facility lies in its ability to economically and efficiently deliver high-quality medical services over the long term. In regions with varying development levels, fully utilizing natural conditions can play a crucial role in achieving sustainable development. For countries like Zambia, being in the process of modernization may, in a sense, provide greater advantages for sustainable development. Resilient and enduring sustainable development goals rely on the synergistic application of diverse green green technologies. Sharing best practice in sustainable hospital infrastructure development among nations can significantly advance global green healthcare initiatives. Thank you for your time and attention today.
Thank you, Li Hui, for that excellent presentation on the various design consideration for Levy Mwanawasa Hospital. And it's great to see all your efforts being recognized by the awards as well. So thank you for your presentation. And now we have a few minutes left for some questions that we have for our panelists. So I would request Lenore, you as well, to please join us by turning on your camera. And we've been having some interesting questions from the participants today, and I would invite everybody to please use the dedicated chat, or not chat, sorry, the Q&A icon to send us your questions for the panelists. So to begin with, I have a general question. It says, how can lessons learned from these projects in Zambia and Mauritius be scaled or replicated in other cities of these countries, or even in other African countries facing similar climatic, economic, or infrastructural challenges? So would you like to go first, Zhuolun?
Yes. Yes, thank you. Thank you for the question. I think as my understanding, that when I visited Zambia and Mauritius and also other African countries, actually, that different countries have their own, climate conditions and also their own, challenges to be in that way. But I think in general, it is very important to have a systematic thinking. Green building is not just like one thing. And then also, like I mentioned, some of the technology used in the green building, actually they can bring in multi-benefit or co-benefit to other things. So for example, so it's very important that we have a teamwork in that regard. So architects should architects should not work alone, and then they should have collaboration with HVAC engineers, structural engineers, and have to work more and then exchange more. And then secondly, I think that the engineers and designers can use different types of simulation software. So you can see that from my presentation. I think also from Edge 2. And then also from Mr. Li Hui's presentation, also that actually the simulation tool is a very good platform that to bring in different engineers or perspective of different focus all together, and then to evaluate whether it is suitable or cost effective or merge different ideas. I think that is also a very good way. And then more importantly, I think that it is not only about technology. Actually, it's about how to use the most suitable and most cost-effective technologies, and to select the ones that in that perspective. So I think that like the system, the platform like Edge and also other systems, it's very helpful, and then they can support, the engineers at the very beginning, to decide, to make decision, or to see that, okay, which kind of energy conservation measurements can be used or should be used. So in that way, that is the what we call low-hanging fruit, maybe. Yeah, so that's all from my side. Thank you.
Thanks, Zhuolun. And Lenore, would you like to follow up?
Thanks. Yes, just to agree, there in every context, we've seen that it doesn't matter which country you're operating in, you would be able to put your building design into the Edge application and then see what that cost would be. So, for example, if you put a design in one country, you might come up with different costs depending on if you're in a different context, because it takes into account the local energy costs, the local water costs, and also the local climatic conditions. So all of that is accounted for within the EDGE application. And what we're seeing more and more is that as people become more aware of what is available, and that to also change certain mindsets that it's so difficult to reach a green building standard. It's actually much more achievable than people might think, using local building materials, using passive design, and some of what has been shared today, then it becomes much more achievable than people might think. So my suggestion is put your design into the app and see how close you might be. You might be pleasantly surprised.
Thanks, Lenore. I think, yeah, that's a good idea, that maybe people can already go and play around the tool a bit to understand better how closely they align with the guidelines. Would you like to go next, Li Hui, please?
Okay, I want my assistant, Ms. Zheng Jia.
So because we IPPR work for as a team, working a lot of hospital designs. So we would like to deliver some ideas about the building a sustainable hospital. As Mr. Li's presentation, the core value of a sustainable hospital depends on whether it can effectively deliver high quality medical services over the long term or not. So a well-organized medical functional framework is the first priority. So like in the case, and we can see we use we integrate the new build part and the renovation part into a coordinated service system, and we design a H-shaped main medical street to combine every part together, ensuring optimal patient flow and the potential to expand in the future. Secondly, those feasible green building technologies mentioned, for example, like the shading system, the indoor light and ventilation control, and the earthwork balancing control, etc., those could be widely replicated and promoted in different regions and countries. And also, like Mr. Chen mentioned before, computer simulation technologies provide a great analytical advantages, particularly in design validation and performance prediction.
Thank you. Thank you for your answer. That's great. And we have a next question for Lenore. So the participants want to know, do you have any perspectives about the green energy building market and EDGE certification in Egypt?
Yes. So we started the Egypt Green Building program a few years ago, and we're actually over 800,000 square meters have already been certified in Egypt. In fact, one of the EDGE projects of the year was the Grand Egyptian Museum, which is next to the Pyramids of Giza. So that's like an iconic building that was certified with EDGE. And so we are really seeing growth in the Egyptian market. There's also been a blended finance facility with CIB. That was an IFC investment in CIB. And that's also helping to stimulate the market, because developers can get concessional financing from the bank specifically for green building construction. So if their project is EDGE certified, they may qualify for some of the facilities offered by the bank. So we're seeing green finance products being offered in the Egyptian market, as well as greater uptake from Egyptian developers, and there have been a number of developers who have certified their buildings. We've also certified some university buildings as well, and we've also done training of EDGE experts There are a number of experts within the local market. We've been working with the Egyptian HBRC, and that's the government green building. They call themselves a green building council. That's the HSBRC, and so we're seeing quite an uptake in the Egyptian market, and we think there's great potential for more growth there.
It's great to hear about the progress being made in Egypt. Thanks, Lenore. The next question is for you, Zhuolun. What is the current status of the practical application of modern control systems, such as model predictive controls, to make HVAC systems more efficient?
Well, that's a good question. Actually, there's a lot of like new technology that are using right now and applied too. So, for example, in the big concept of smart city, actually they do this control, based on this smart city concept, and then they have been integrated into the what we call, centralized, control system in the building, so that the building management team can control the HVAC system much smart. And then also, as I see right now, actually, I'm in China, and then in the past 2 weeks, actually, I have been, traveling in China, and then did some on-site visits in different projects. And then I see that some of the projects, actually, they are using AI, to predict, the cooling, heating, electricity, and even domestic hot water. For example, the hotel that I'm living in right now, actually, they are trying to apply this AI, apps into their domestic hot water, and then also the solar, the PV panels in their system, so that they know that, okay, in the coming few hours, what kind of demand they are having, and then how they can control their thermal storage or battery storage system to better be aligned with the one is to better align with the demand, but the secondly also to use the different tariff of the electricity so as to save money. So these kind of things, I think, it become more and more common, not only in the big or large scale of buildings, the public buildings, but also they have been used in like hospitals, hotels, essential. So I believe that that would be the future, the AI aided control system.
Thanks, Zhuolun, and for bringing your perspective from China as well. The next question is for the IPPR team. So how did you balance energy efficiency and infection control requirements, such as ventilation needs, in the design of these hospitals? And are there any trade-offs between green building standards and medical functionality?
Our opinion about this is energy efficiency and infection control can and must coexist. While higher ventilation rates for isolation rooms do increase energy use, our experience shows smart strategies can offset this. The crucial thing is to first identifying non-negotiable clinical needs. Then, through evaluation of multiple feasible methodologies and technological alternatives, we implement the most context-appropriate integrated solution. That's all.
Thank you. And the next question we have again is for the EDGE certification. So Lenore, if the basis for the certification is on the local building standards of the respective country, what happens when the local building code is inadequate and in many cases non-existent, for example in Zambia? And how do you ensure a minimum quality level?
So in those cases, we do have a global minimum that we use if there isn't a local building standard that is of sufficient a locally available standard that's sufficient. So we do have that local minimum, that global minimum that we use in those cases, because yes, that is the case in some countries, that there isn't a very good local standard available.
Thanks, Lenore.
Yes. Sorry, Trupti, if I may, I would like to add on what Lenore mentioned, and then also, that actually that is one of our deliverables of the GPUC project, is that we are trying to set up this benchmarking for electricity, cooling, heating, consumption for different types of buildings for both Zambia and Mauritius. And then once we set up this benchmarking, and then we hope that this can have some references, for example, whenever you compare the baseline of business as usual to your proposed design, so then you can use the benchmarking database in the future. And then this is also one of the suggestions I would like to make for the stakeholders in Zambia and Mauritius that try to set up this benchmarking database for different type of buildings. Yeah, thank you.
Thanks, Zhuolun. Thanks for complimenting the answer. And we have, maybe we take one last question. This is dedicated to the IPPR team again. So how might the design principles of energy efficiency used in these hospitals be adapted to other regions in Zambia and Mauritius or other public building types? And were local cultural practices also incorporated into the design?
Yeah, I think we mentioned before that a lot of utilization and practitioner ways to dedicate the green and the sustainability building in the PPT. And we like to add another one is the local cultural practices incorporated in the design process. This is a very good question, and we did a lot of research at the beginning of the design process, and then we combine and we collect the social and cultural development and also the climatical condition and all the practices and into the practitioner. Yeah, so that's all.
We also had a slide in the presentation where we could see the different design consideration where you took into account also the local design practices and merged it very well with the traditional Chinese designs as well. So thank you for your answer, and I think now we are a little bit over time, so maybe it's time that we end the panel discussion. And on that note, I would like to say thank you, and we have arrived at the end of the training program. So a big thank you to all our panelists for your valuable insights and thoughtful contributions today. Your expertise has added real depth to our session and the entire training series. And for our participants, thank you for your active engagement and thoughtful questions throughout the sessions. And we hope this training has provided you with some valuable tools and perspectives to support your work in making buildings more energy efficient and sustainable. I would also like to thank our webinar broadcast focal point, Aris, who is working behind the scenes, making sure everything is running smoothly. So thank you. And though this marks the end of our training, we hope that it's just the beginning of some continued collaboration and knowledge exchange between our focal countries and beyond. And if you'd like to learn more about the GPUC project, then please feel free to get in touch with us. So on behalf of UNEP CCC, thank you all once again, and we look forward to seeing the impact of your work in your cities and communities. So thank you, goodbye, and take care.